In this trick video, we'll discuss how to multiply two-digit numbers which are having the same first digit, but the sum of the last digits is 10. So exactly what do I mean by this? Let's take an example. If I write 54 multiplied by 56. Now notice in both these numbers, the first digit is the same, it is 5. But if you look at the second number, so you have a 4 here and a 6 here. And if we add 4 plus 6, we will get a 10. Let me write it down. So the first number 5 and 5 is same. But if we look at the other digits, 4 and 6, if they add up to 10, 4 plus 6 is equal to 10, then this trick will be applicable. So what is the trick involved? If I write down the numbers again, 54 into 56. Let's write it down in the column notation, 54 multiplied by 56. Now, of course, we are not going to do traditional multiplication. So what is the trick involved? All we need to do, look at the number on the left-hand side, which is a 5. We will multiply 5 with the next number. The next number after 5 is 6. So 5 into 6 will become 30. That's step 1. For step number 2, we look at the other digits 4 and 6. So all we need to do is multiply 4 and 6 together. So 4 into 6 is equal to 24. And that we can write on the right hand side. And that's it. This is the answer 3024. So we will write 54 multiplied by 56 is equal to 3024. All right, let's take one more example. If I write 73 multiplied by 77, first you need to identify, does these numbers satisfy the condition? And what was the condition? That the first digit should be the same and the sum of the last digits is 10. We can see here the first digit is 7 and the next two digits, 3 and 7, they add up to 10, which means we can employ this trick. So what do? The number on the left hand side is 7. So we multiply 7 with the next number, which is 8. 7 8s are 56. And then we multiply the other two digits. 3 multiplied by 7 will be equal to 21, which we will write on the right hand side. That means we can write 73 into 77. This is equal to 5621. That's it. Wasn't this easy? This is to be done orally in the school exams. But please do not forget to apply any trick. You need to remember what are the conditions involved. So in this particular case, the first digit should be the same and the next two digits, for example, 3 and 7 in this case, those should add up to 10. Let's take one more examples. Let's say 89 multiplied by 81. Before we proceed ahead, let's check the condition. So the first digits is the same, it is 8. And the next two digits, 9 plus 1 is equal to 10. Condition satisfy. Now we can apply the logic. So we have 8 on the left hand side. Multiply 8 with the next number. 8 into 9 will be equal to 72. Now we write 9 into 1, which is equal to 9. Now, this is where we need to be careful. We cannot write 9 as it is. The rule here is if you multiply the other two digits, it should be a two-digit number. So how do we make 9 into a two-digit number? All we need to do is just put a 0 in front of it. And that's it. This is the answer 7209. We can write 89 multiplied by 81 equals to 7209. All right, let's take one more similar example. Let's say if I take 112 and 118. So I have taken two three-digit numbers. The logic will be applicable even here because look at the numbers 11 and 11, that is the same. And the next two digits, 2 and 8, they add up to 10. Steps involved are the same. So take the entire number 11 and multiply it with the next number, which is 12. 11 into 12 is equal to 132. Then we take 2 and 8. 2 8s are 16, which is already a two-digit number. So we will put 16 here. 13216, which means we can write 112 multiplied by 118 is equal to 13216. And that is how we solve questions of this type. Before we end, I will repeat the instruction. Please remember all the trick videos are only applicable with the correct conditions. So before you apply any trick, please be very careful of the conditions. In this video, we'll discuss how do we find squares of any number which is close to 100. Let us take an example. Let's say if you have to find the square of 101. The answer to this can be found in just 1 or 2 seconds if you know the trick involved. Before solving this, let us understand the formula which will be used to solve this. So the formula goes like this. If you have 100 plus a, so any number which is close to 100, and if you are trying to find the square of it, so the answer will be 100 plus 2a, And then we write a square on the right hand side, where a square is a two-digit number. Let's apply this formula. So in this case, 101 is 1 ahead of 100. So let me write 101 can be written as 100 plus 1, which means the value of a is 1. So in the answer, the left hand side will be 100 plus 2 into a is 1. So we get 102 on the left hand side. And for the right hand side, we have a squared. A is 1, so 1 squared will be equal to 1. But 1 is not a two-digit number. So how do we make it two-digit? We will put a 0 on the left side, which will become 0, 1. And this 0, 1 will be put on the right-hand side of the number. And this is the answer. So we can write 101 whole squared is equal to 10201. Let's apply the same logic for, let's say, 104 whole squared. So in this case, what is the value of a? How much is 104 ahead of 100? It is 4. So 104 can be written as 100 plus 4 whole squared. So the value of a is 4. So according to the formula, we have to write 100 plus 2a on the left hand side. So we write 100 plus 2 into a is 4. This will be the left hand side, and on the right hand side, we have to write a square, which should be a two-digit number. Here the value of a is 4 and the value of 4 square is 16. 16 is already a two-digit number, which we can write on the right-hand side. On the left, we'll have 100 plus 2 into 4. 2 fours are 8. And so 100 plus 8 will become 108. So this is the answer. 104 whole squared is equal to 10816. And that's how we solve questions like this. So consider this as case number 1 when we were dealing with numbers which were above 100. Let's consider case 2, which will be the numbers which are below 100. So let's do that. Case number 2, let us take an example of, let's say, 98. And we have to find the 98 squared. The formula in this case will be similar. Let me write down the formula. 100 minus a whole squared. The answer will be 100 minus 2a on the left, and on the right hand side it is a square, where a square again should be a two-digit number. Let's apply the same logic here. So 98 can be written as 100 minus 2, hence the value of a is equal to 2. So on the left hand side we will write 100 minus 2 into 2. On the right hand side we will write 2 square. Now 2 square is equal to 4, which is not a two-digit number. So let's add a 0 on the left-hand side. 04 will be the right-hand side. On the left-hand side, let's solve this. 100 minus 2 into 2 is 4. So 100 minus 4 will get us 96. Hence, we will write 98 squared is equal to 9604. Let's take one more example, 95 squared. Now, earlier we had done the same expression using a different trick. Let's revise that trick. So it was 95 multiplied by 95. In the earlier trick, what we had done, on the left-hand side, the number is 9. So we multiply 9 with the next number, which is 10. 9 into 10 will become 90. That's the left-hand side. On the right-hand side, we will just take the square of 5. 5 square will be 25. Hence, 95 squared is equal to 9025. So we found the answer using that original trick. But the same answer can be found using this formula 100 minus a. So in this case, we'll write 95 can be written as 100 minus 5, which means the value of a is equal to 5. According to the formula, the answer is 100 minus 2a on the left-hand side. On the right-hand side, we'll write a square, where a square is a two-digit number. All right, let's put the value of a is equal to 5. On the left, we'll get 100 minus 2 into 5, which is 100 minus 10, which will get us 90. These are the digits on the left-hand side. And on the right, we have a square, which is 5 squared, which can be written as 25. So the square again is 9025. So whichever trick we use, the answer is supposed to be the same. And that is how we find the squares of numbers which are close to 100 by using the two formulas. The first one is 100 plus a whole squared, and then second is 100 minus a whole squared. In speed subtraction also, we employ the same logic. So the expression is 162 minus 21 minus 12 minus 10. Is it possible to solve it just within 5 seconds or even lesser? Yes, if we understand the principle of digit sum. Let's focus on the expression. Now, all we need to do is figure out the digit sums of all the numbers, starting with 162. Let's do it orally. What's the digit sum of 162? 1 plus 6 will give us 7. 7 plus 2 will be 9. So the digit sum of 162 is equal to 9. Digit sum of 21, 2 plus 1 will give us 3. Digit sum of 12, 1 plus 2 will give us 3. And finally, the digit sum of 10 will be 1 plus 0, which is just 1. And now all we need to do is just subtract. So since in the expression you have minus signs, so that's why we do 9 minus 3 minus 3 minus 1. Let's solve this. 9 minus 3 will give us a 6, and then we can write down the remaining expression. 6 minus 3 will give us a 3, and then we write minus 1. 3 minus 1 will give us 2. Hence, the digit sum of the entire expression needs to be equal to 2. Now, let's see which option can give us digit sum as 2, starting with option A, 129. So the digit sum will be 1 plus 2 is a 3, 3 plus 9 is a 12. Now the digit sum of 12 is 1 plus 2, which will give us 3. Hence option A is not the answer. In option B, the digit sum is 1 plus 1 plus 5, which will give us 7, which means that is also not the answer. Coming to 118, the digit sum will be 1 plus 1 is a 2, 2 plus 8 will be a 10, and the digit sum of 10 is 1 plus 0, which will give us 1, which means even this is not the answer. Hence, option D is the answer, but just to cross check, let's find out the digit sum of 119. So 1 plus 1 plus 9, 1 plus 1 will be 2, and then if we add 9 to 2, we'll get 11, and the digit sum of 11 is 2. Hence, the digit sum in option D matches with the digit sum of the entire expression, and that's why we can select option D as our answer. I hope you have understood the logic. All we have done is find the digit sums of all the numbers, and then we use the original operators. By operators, we mean here minus signs. Now let's solve another question based on the same principle. Question number 2. Now for this, I want you to pause the video. Please try to solve this question on your own and only then proceed ahead to watch the solution. So yes, go ahead, pause the video and solve it. This question is not entirely straightforward. The expression was 461 minus 253 minus 104. So we will observe something peculiar in this. So let's see. What will be the digit sum of 461? 4 plus 6 is 10. 10 plus 1 is 11. And the digit sum will be 2. What about 253? 2 plus 5 is a 7. 7 plus 3 is 10. The digit sum of 10 is 1 plus 0, which is 1. And 105, the digit sum will be 1 plus 5 will give us 6. Now we will put the minus signs. 2 minus 1 minus 6. This is where it gets tricky. 2 minus 1 is fine. That will give you 1. But if we write the remaining expression 1 minus 6. Now let us consider two cases. Let's say you know what 1 minus 6 is. So 1 minus 6 is equal to minus 5. Now the digit sum can never be negative. To make it positive, we will use a simple logic, and the concept is we have to just add number 9 to it. So now the expression becomes 9 minus 5, which will give us 4. And hence the digit sum of the entire expression needs to be equal to 4. So this was case 1 if you knew that 1 minus 6 is equal to minus 5. Let's say you do not know how to find 1 minus 6. Then what do? We will take the original expression 1 minus 6 and then again add a 9 to it. And now this is solvable because now you can add the 9 and the 1. So 9 plus 1 will give us a 10. And then we will subtract the 6 from it. So 10 minus 6 will give us 4. So in either way, the digit sum comes out as 4. Now let's see which option can get us the digit sum as 4. Starting with option A, 113 digit sum will be 1 plus 3, which is 5, which means this cannot be the answer. Digit sum of option B is 1 plus 7, which is 8, which is also wrong. For option C, the digit sum will be 1 plus 0 plus 3, which will give us 4, which means that is the answer. Just to cross check, let's check out option D. Digit sum will be 1 plus 2 plus 3. 1 plus 2 is 3, 3 plus 3 is 6, which means the digit sum of option D is 6. Hence, option C was the answer. So, did you observe the trick involved? In case we are dealing with negative numbers, all we need to do is just add the number 9 in order to find the digit sum. Now, let's solve one more question, which will involve both addition and subtraction. So, I want you to pause this video. Please try to attempt this question on your own. Use the same concept of digit sum and see if you can find the right answer. So, pause the video and please solve. Let's find the digit sums of all the numbers, starting with 56. 5 plus 6 will give you 11, and the digit sum of 11 will be 1 plus 1, which is a 2. 278. The digit sum will be 2 plus 7 will be a 9. 9 plus 8 will give us a 17. But the digit sum of 17 will be 1 plus 7, which is equal to 8. Hence, the digit sum of 278 will be 8. Coming to 901. 9 plus 1 is 10, and the digit sum of 10 is 1 plus 0, which is 1. Coming to 512, digit sum will be 5 plus 1 is 6, 6 plus 2 is 8. So 5 plus 1 plus 2 is 8. 37 digit sum will be 3 plus 7 is 10, and 10 digit sum is 1. And now all we need to do is just put the sign. So we have a plus 2 pluses and 2 minuses. So our expression will become 2 plus 8 plus 1 minus 8 minus 1. Let's solve this. 2 plus 8 is 10. 10 plus 1 is an 11. Let's write it down. This is 11. And then we rewrite the remaining expression. So 11 minus 8 will be 3. 3 minus 1 will give us 2. Hence, the digit sum of this expression needs to be equal to 2. Now we will see which option can get us the digit sum as 2. Let's start with option A, 687. Let's write it down, 687. The digit sum will be 6 plus 8 plus 7. 6 plus 8 is a 14. The digit sum of 14 is 1 plus 4 will be a 5. And then we add 7 to it. 5 plus 7 will be a 12. Digit sum of 12 is 1 plus 2 is equal to 3. Now we can write that in the option A, the digit sum is equal to 3. Employ the same logic for option B, 656. 6 plus 5 is 11. The digit sum of 11 is 2. And that 2 plus this 6 will get us 8. Hence, option B, digit sum is 8. Hence, A and B are both incorrect because we need the digit sum as 2. Let us look at option C, 696. Now, let me write this on the right-hand side. So, for 696, the digit sum will be 6 plus 9 plus 6. 6 plus 9 is equal to 15. The digit sum of 15 will be 1 plus 5 is a 6. And then we add 6 and 6 to get a 12. And the digit sum of 12 will be 1 plus 2, which is equal to 3. Hence, in option C, the digit sum is 3, which means that also is not the answer, which means option D has to be the answer. But just to cross check, let's identify what's the digit sum of 686. So let's do it. 6 plus 8 plus 6. So 6 plus 8 will get us 14. 14 is not a single digit number. So we add them again. 1 plus 4 will give us 5. And then we add the 6 to it. So 5 plus 6 will get us 11. Digit sum of 11 will be 1 plus 1, which is equal to 2. Hence, the digit sum of 686 is in fact 2. And that is why D was the answer.